Today, we're diving deep into the hidden world of real-time video. We're going to figure out what really separates a flawless video call from a total, frustrating digital collapse. Let's get right into it.
You know the feeling, right? We've all been there. You're on a call, it's going great, and then a few more people join, then a few more. And suddenly, everything just grinds to a halt. Videos freeze up, the audio starts chopping, the whole thing just falls apart. And it's not always your internet connection. A lot of the time, it's the technology behind the scenes failing to scale.
The unsung hero, or, sometimes the villain, of your video call is this thing called a Selective Forwarding Unit, or SFU for short. And really, understanding what this thing does is the key to figuring out how some services can handle hundreds of people without breaking a sweat, while others just crumble.
Okay, so think of an SFU like a super efficient traffic cop for all that video data. Instead of taking everyone's video, mashing it all together into one big stream, which is incredibly tough on a processor, the SFU does something way smarter. It just takes your video stream once and then forwards it out to everybody else who needs to see it. It's really the secret sauce that makes most modern, large-scale video platforms even possible.
But here's the thing. Not all SFUs are built the same. Not even close. So back in 2018, some researchers at Cosmos Software set out to answer a simple question. Which open-source SFU could actually handle the most pressure? They wanted a real, scientific, head-to-head battle.
So they chose 5 of the biggest names in the open-source world at the time to step into the ring. You've probably heard of some of these: Jitsi, Janus, Meduse, Corinto, and a bit of a newcomer back then, MediaSoup. Each one was about to face a serious stress test.
The mission was pretty straightforward, actually. Just push these servers until they break, find their absolute limit. They wanted to see what would happen in a massive real-world video conference, but totally simulated and controlled.
So to make it a fair fight, they set up this really robust testing rig. They put each SFU on its own powerful virtual server, and then they basically unleashed an army of virtual clients. These weren't real people, but bots programmed to act like them. And they just kept joining conference rooms, 7 people at a time, adding more and more rooms to really crank up the pressure and see what would happen.
So what happened when things got intense? Well, the results weren't just a little interesting, they were incredibly dramatic. Let's take a look at the data.
Okay, this one graph pretty much tells the entire story. Along the bottom, you have the number of people joining the calls, and on the side, you've got video bitrate. You can just think of bitrate as video quality. The higher the line, the better the video looks. And you can see it right away. A few of these servers handle the load pretty gracefully, but the others, well, they just fall right off a cliff.
And this right here just perfectly illustrates the difference. Over on the left, you've got Jitsi. Look at how the quality holds steady. It holds, and then bam! Right around 245 users, it just completely dies. The bitrate flatlines to 0, the server literally stops sending video. Now look at MediaSoup on the right. It just handles the pressure, the bitrate adjusts a little, but it never ever collapses. It just keeps scaling smoothly all the way up towards 500 participants.
The final numbers are even more telling. I mean, look at this. When the dust settled, a staggering 81% of Jitsi's video streams had just failed. Janus and Corinto weren't much better, both in the 40s. Meduse did pretty well, actually, only 10%, but MediaSoup, just 3%. That's almost nothing. It's a huge difference. So what on earth was it doing that was so different?
I mean, how did this one SFU manage to just blow the others out of the water like that? It wasn't just a few little tweaks or clever optimizations. The answer is actually much deeper. It was a radical bet on a completely different way of thinking about the problem.
So let's pop the hood and take a look inside. Let's see what actually makes the MediaSoup engine tick.
This quote from Iñaki Bacais Castillo, one of MediaSoup's co-founders, really gets to the core of it all. He basically questioned the whole idea of how SFUs were being built. He asked, why do I have to build this big separate server that my own app has to talk to? He just wanted to focus on the media part. And that simple question, what if it wasn't a server, but just a library? That changed absolutely everything.
And this chart really lays out the 2 different worlds. A traditional SFU is like buying a pre-built car. It does its thing, and your application has to communicate with it in a very specific way. MediaSoup, on the other hand, is like being handed a high-performance engine. It's a library, a building block, that you put inside your own application. It gives you all the raw power without any of the extra baggage you don't need.
And being a library unlocked its other secret weapon, this brilliant multi-process design.
So instead of having a bunch of different threads all trying to use one CPU core, which can get messy and create bottlenecks, MediaSoup just launches separate C++ processes they call workers. Each worker gets its very own dedicated CPU core. This keeps everything clean, it isolates the workload, and it makes scaling up incredibly efficient and predictable. You need more power? No problem. Just spin up another worker.
So, what's the big takeaway here? If you're building a real-time app today, what does this all mean for you? Well, it really comes down to a classic trade-off between two different philosophies.
First, it teaches us that architecture is destiny. That single decision, to be a library instead of a standalone server, had these enormous downstream effects on performance. Second, by giving developers these raw, unopinionated building blocks, MediaSoup gives them incredible power and flexibility. But that's the trade-off, isn't it? It's a wildly powerful engine for sure, but you have to know how to build the car around it. It's not for beginners.
And that really leaves us with a fascinating question for the future. As we keep demanding more and more from our real-time apps, which of these approaches is going to win out? Is it the simple all-in-one solution that gets you going fast? Or is it the powerful low-level engine that gives you limitless potential, but only if you're willing to get your hands dirty and build it yourself? The answer to that is probably going to shape the next generation of how we all communicate online.